nothing.
Oh, calm down. What seems to be the problem, miss?
My bathroom sink used to be clean and shiny, but now it's dark and covered with stains. I only use these products, but I don't know what went wrong.
Interesting. So, did you use any other cleaning products? Baking soda, lemon, or water, maybe?
But I only use them.
These are the main suspects.
I was only trying to remove their stain.
And I was helping clean grease and dirt.
Don't worry, guys. We can solve this scientifically by determining the pH of each household product. How would that help? Different cleaning agents have different pH values. Their effectiveness depends on whether they are acidic, basic, or neutral.
Then let's examine the evidence.
But before we begin the investigation, let's understand what pH is.
Whereas, when we think about making our home clean and spotless, we rush into picking any cleaning product without a second thought. However, the truth is that there is always something hidden between the shine, scrubbing and polishing of the surface, which is the pH level. It is necessary to understand the pH scale because it is not only for the science, but also for a proper cleaning at home. The pH level of a certain cleaning agent directly depends on its interaction with a surface. That is why sometimes cleaning can damage the surface instead of making it clean. This session revealed the secrets of pH scale and chemistry of daily cleaning solutions.
Today, we are exploring the foundational chemistry behind the theory of pH. The concept dates back to 1909 when a Danish scientist named Søren Sørensen defined pH as a way to measure acidity. Mathematically, it's quite straightforward. pH is simply the negative logarithm base 10 of the hydrogen ion concentration. But to really see how this works in a solution, we have to look at how water behaves. Specifically, at 25 degrees Celsius, water molecules naturally self-ionize into hydrogen and hydroxide ions. The equilibrium constant for this process, which we call the water ionization constant, gives us a constant value of exactly 1.0 times 10 to the power of negative 14. When we take the negative logarithm of that entire expression to convert it into a standard scale, the exponents flatten out and the math simplifies beautifully into a universal rule: pH plus pOH equal to 14. This simple balancing act is what allows us to instantly calculate the chemical state of any aqueous solution at standard room temperature. So, what does this look like when we actually step into the laboratory? Because the scale is logarithmic and negative, it operates inversely. A high concentration of hydrogen ions yields a low pH value, signaling an acidic solution. On the flip side, a lower concentration means a higher pH value, indicating an alkaline or basic solution. We define a pH below 7 as acidic, exactly 7 as neutral, and anything above 7 as alkaline. To measure this value in practice, we rely on three common tools depending on the precision we need. For a quick qualitative check, we can use litmus paper, where blue turns red in acid and red turns blue in bases. If we want a better visual estimate, a universal indicator provides a beautiful color spectrum across the entire 1 to 14 range. Finally, when we need exact, highly accurate decimal data for our experiments, we use a digital pH meter to measure the precise electrical potential of the solution. That covers the core principles of pH theory.
Now let's take a look at the demonstration on how to determine pH in household cleaning products. Firstly, label 2 containers as dishwashing liquid and vinegar and measure a small amount of each solution into their respective containers. By using a fresh strip of red litmus paper, dip the litmus paper into the solution for a few seconds and observe for any color changes. Repeat the same steps by using a fresh strip of blue litmus paper. This process is repeated again using the vinegar solution. Finally, the color changes are compared to determine the nature of each substance. If blue litmus paper turns red, substance is acidic, whereas if red litmus paper turns blue, the substance is considered to be alkaline. Based on the observations, vinegar is identified as an acidic substance, while dishwashing liquid is identified as an alkaline substance. That will be all for this demonstration video. Thank you for watching.
Let's take a look at the experimental results of our litmus paper test as displayed. First, we tested vinegar. Its pH type is classified as acidic when applied to the indicators. It has no effect on red litmus paper, meaning it stays red, but it excessively turns blue litmus paper red. Next, we have dishwashing liquid, which falls under the basic pH type. Unlike the vinegar, the dishwashing liquid turns red litmus paper blue, while it has no effect on the blue litmus paper, leaving it so it stays blue.
Now, based on our results and discussion, we can see why pH is important in everyday cleaning. The pH of cleaning product influences how it interacts with sink surfaces and explains why different products can produce different effects on the appearance of the sink. For example, vinegar is acidic. Although it is effective for cleaning, repeated exposure can react with certain sink materials or their protective finish, causing the surface to gradually lose its shine and become dull. In contrast, dishwashing liquid is usually neutral to mildly alkaline. Because it is gentle on sink surfaces, it is less likely to affect the sink's finish and is generally more suitable for regular use.
Now moving on to our discussion, let's consider the scientific aspects of our experiment as illustrated. The first step is the pH mathematical formula for hydrogen ions concentration is provided as negative log 10 H plus equals pH. This pH value is controlled by water ionization at 25 Celsius and the equation becomes pH plus POH equals 14, where pH less than 7 means acidity and more than 7 means alkalinity. Quantitative results on litmus paper show this difference well. Acids like vinegar turns blue litmus red, and alkali washing liquid turns litmus paper blue. Finally, this chemical reaction has serious practical consequences. Strong acidity of vinegar leads to fast reactions with particular substances in sink and causes dullness over time. On the contrary, dishwashing liquid is neutral or alkaline, which helps to remove grease from surfaces without destroying original gloss. After examining all the evidence, we successfully determined the pH of these two household products.
Our results show that vinegar are acidic while dishwashing liquid are basic. This investigation helps us understand why different cleaning products behave differently and affect surfaces in different ways. We also learned that acidic cleaning agents are effective for removing mineral deposits and certain stains.
Meanwhile, the basic cleaning agents are effective for removing grease and dirt. By understanding pH, we can choose the right cleaning product safely and effectively.
In conclusion, pH plays an important role in the effectiveness of household cleaning products. The mystery of the dull bathroom sink has been solved. Case closed.